Good morning, respected lecturers. We are Group 6 and today we are very pleased to present our projects, Enterprise Cloud-based student management system using AWS Cloud Service. My name is Chim Liang and together with my teammates Kang Zhao Wan, Lim Zhu Hong and Terry Ang Yen Ting, we developed this project as part of the TCC 4223 Introduction to Cloud Computing course. Today, our presentation will explain why we migrate a traditional student management system from an on-premise environment to AWS Cloud. We will introduce the problem faced by the existing system, explain our proposed cloud solution, describe our AWS architecture and service, compare cloud computing with traditional infrastructure, and finally discuss the benefit of conclusion of our project. First, let's look at the current on-premise system. Our student management system is developed using PHP as the programming language together with the SQL database. Both the web application and the database are hosted on a single physical server. The design works reasonably well when there are only a small number of users. However, as more students and administrators begin accessing the system simultaneously, several serious problems appear. The first problem is the single point of failure. Since only one physical server is responsible for running the entire system, any hardware failure, software crash, power outage, or network interruption will immediately make the whole application unavailable. This means students cannot check their academic record, register for course, or access important university information. Administrators are also unable to update student record or manage academic data until the server is restored. The second limitation is manual backup and maintenance. The IT administration must manually perform regular database backup, install software updates, monitor system performance, and replace software whenever necessary. Besides consuming a lot of time, manual maintenance also increases the possibility of human error. For example, forgetting to perform a database backup could result in permanent data loss if the server suddenly fails. Another important limitation is limit scalability. Suppose thousands of students access the system at exactly the same time during course registration or when academic results are released. The physical server may not have enough CPU, memory, or storage resource to support so many current users. In a traditional environment, increasing capacity usually means purchasing new hardware, installing additional server, and manually configuring the infrastructure. This process requires significant time and financial investment. The fourth limitation is performance the degradation during high traffics. When server resources become overloaded, users may experience slow response time, delay page loading, or even complete service interruption. Poor performance directly affects user satisfaction and may reduce confidence in the university information system. Finally, maintaining physical infrastructure result is higher admission costs. The university must continuously invest in hardware replacement, electric cooling system, server room, and maintenance staff. Over time, these operation costs become very expensive. To overcome this challenge, our group proposed migrate the student management system to Amazon Web Service, commonly known as AWS. Cloud computing allow organizations to use computing resources through the internet instead of purchasing and maintaining physical server. AWS provide many managed services that automatically handle infrastructure management, security, scaling, and system availability. Our proposed solution improves several important areas. Firstly, scalability because crude result and automatically increase or decrease according to user demand. Secondly, availability is because multiple crude service ensure the availability remain only even if one server fail. Thirdly, is reliability because AWS provide built-in reduced density and fault tolerance. Fourth is performance because workloads are dispersed among multiple servers instead of relying only one machines. Finally, flexibility because administration can monitor and manage the entire system through the AWS management console from anywhere. In addition, cloud computing prepare the university for future digital transformation. In if new service such as online examination, attendance system, AI powerful student analysts, or mobile application are introduced, AWS provide enough flexibility to support future expansion without rebuilding the entire infrastructure. Therefore, cloud migration is not only the solution for current challenge, but also a long-term investment that supports continuous system growth. Now, I would like to pass the presentation to our second speaker, who will explain the AWS architecture diagram.
So my name is Kang Zawan. Now I will explain the AWS architecture diagram shown in the center of our poster. This architecture demonstrates how different AWS services work together to build a reliable, scalable, and highly available student management system. The entire process begins with user. Student, lecturer, and administration access the student management system through the internet using computer, tablet, or smartphone. Their requests are first received by the Elastic Load Balancer. The primary responsibility of the Elastic Load Balancer is to distribute incoming traffic across multiple application servers. Instead of directing every request to one server, it balances the workload evenly among all available EC2 instances. This prevents individual users from becoming overloaded while improving overall system performance. Load balancing also provides better user experience because requests are processed faster and response time remain consistent. Behind the load balancer are multiple Amazon EC2 instances. Amazon EC2 stands for Elastic Compute Cloud. This virtual machine hosts our PHP student management system. Unlike traditional physical server, EC2 instances can be created within minutes whenever additional computer resources are required. These EC2 instances are managed by the auto-scaling group. Auto-scaling continuously monitors system performance, CPU utilization, and incoming traffic. During peak periods such as course registration or examination result announcement, auto-scaling automatically launch additional EC2 instances. Once traffic returns to normal, unnecessary instances are automatically terminated. This automatic scaling ensures that user always receive good performance while minimizing unnecessary cloud costs. Instead of paying for ID served throughout the year, the university only pay for additional resources when required. Another important feature is fault tolerance. If one EC2 instances become unhealthy because of software error or hardware failures, the load balancer automatically stops sending traffic to that instance. At the same time, auto-scaling launch a replacement instance. This entire recovery process happens automatically without requiring administration intervention. As a result, users experience little or no service interruption. The application server communicates with Amazon RDS, which stores all student information inside a managed MySQL database. Amazon RDS automatically performs software update, security patch, and regular backup. It also supports high availability and disaster recovery. Compared with manually maintaining database server, Amazon RDS greatly reduces administrative workload while improving database security and reliability. Overall, this architecture demonstrates how AWS combines multiple services into one integrated cloud solution. Each AWS service performs a specific task, but together they provide a secure, scalable, and efficient platform capable of supporting thousands of concurrent users. So now I will invite our third speaker to explain the AWS service used in this project.
Okay, now I will introduce the AWS service that we use in our project and explain why each service is important. When designing our cloud-based student management system, we select for main AWS service. These services work together to provide a secure, scalable, and highly available solution. The first service is Amazon EC2, which stands for Elastic Compute Group. Amazon EC2 is responsible for hosting our student management system application instead of using a physical server. EC2 provider feature server in the cloud that can run our PHP web application. One of the biggest advantage of EC2 is flexible. We can choose different instance type depending on the workload. If the system require more CPU power or memory, we can easily upgrade the EC2 instance without purchasing new hardware. Another advantage is the EC2 instance can be launched within minutes. This allows the university to respond quickly whenever more computing resources are needed. Compared with a traditional server, EC2 reduce hardware costs and provide much greater flexibility. The second service is Amazon RDS or Relational Database Service. Amazon RDS is used to store all student information, including student profile, course registration, examination result, and other academic record. Instead of installing and maintaining MySQL manually, Amazon RDS manages the database automatically. For example, AWS perform regular database backup, software update, and security patching without requiring much administrator involvement. This greatly reduces maintenance work and minimize the possible of human error. Another important feature is data recovery. If unexpected problem occur, Amazon RDS allow administrator to restore the database quickly from automatic backup. This ensures that important university data is protected and can be recovered whenever necessary. The third AWS service is the Elastic Load Balancer. As mentioned earlier, the load balancer describes incoming request across multiple EC2 instances. Without load balancing, all users would connect to one server, causing heavy traffic and slow performance. With Elastic Load Balancer, the workload is shared equally among multiple application servers. As a result, users experience faster response time, better system performance, and fewer service interruptions. In addition, the load balancer performs health check on each EC2 instance. If one server becomes unhealthy, traffic is automatically redirected to healthy server. The, this improves both availability and reliability. The fourth service is the automatic scaling group. Auto scaling group adjusts the number of EC2 instance according to system demand. For example, during normal school day, only a few servers may be needed because fewer students are using the system. However, during course rejection of examination result announcement, thousands of students may log in at the same time. Auto scaling detect the increased workload and automatic launch additional EC2 instance. Once traffic decreases, these extract instances are automatically terminated. This feature provides two major advantages. Firstly, users always receive good performance because there are enough servers available. Secondly, the university only pay for additional server when they are actually needed. This makes cloud computing much more cost effective. Now let us compare the traditional on-premise system with our AWS cloud solution. The first comparison is cost. Traditional system require organization to purchase expensive server network equipment and software license before the system can be deploy. In concept, AWS use a pay-as-you-go pricing model. This means the university only pay for the resource it actually use, reducing unnecessary expense. The second comparison is scalability and on-premise system requirement. Manual hardware upgrade whenever more resources are needed. This process can take days or even weeks. With AWS, resources are automatically scaled within minutes using auto-scaling. The third comparison is availability. A traditional system depends on a physical server. If that server fails, the entire system becomes available. AWS improves available by using multiple EC2 instances together with elastic load balancer and auto-scaling. Even if one server fails, the application continue running. The fourth comparison is backup. Traditional systems depend on administrator to perform backup manually. This increases the risk of forgotten backup or lost data. Amazon RDS automatically perform backup and allow quick recovery whenever necessary. The third comparison is accessibility. Traditional systems are often limited to use inside the university network. Cloud-based system can be accessed secure from anyone with an internet connection. Students can log in using laptop, tablet, or smartphone whenever they are on campus or studying remote. Finally, regarding maintenance and reliable, AWS manage most of infrastructure automatic. This reduces the workload of IT staff while providing a high reliable platform with built-in redundancy and fault tolerance. Overall, AWS offer a modern solution that is more efficient, flexible, and reliable than traditional infrastructure. Now, I would like to invite our final speaker to conclude our presentation.
Good day, teacher. I will now explain the benefits of our cloud solution and conclude today's presentation. By immigrating our student management system to AWS Cloud, we achieve several important improvements compared with the traditional on-premise system. The first benefit is high availability. Because our application is deployed across multiple EC2 instances behind an elastic load balancers, user can continue accessing the system even if one server experiences technical issues. This greatly reduces downtime and ensures continuous access to important academic service. For a university, high availability is extremely important because students may need to register for course, check examination result, or submit important information at any time. The second benefit is better security. AWS provides many security features that help protect both the application and sensitive student information. For example, administrators can control who is allowed to access AWS resource through identity and access management, commonly known as AIM. AWS also provides security monitoring, encryption, and network protection that improve overall system security. Protecting personal student information is extremely important because universities store confidential academic record and personal data. The third benefit is automatic backup. Using Amazon RDS, database backup are created automatically according to predefined schedule. If unexpected situation occurs, such as accidental deletion or hardware failure, administrations can restore the database quickly. This significantly can reduce the risk of permanent data loss. Automatic backups also reduce the workload of IT staff because manual backup produced are no longer required. The fourth benefit is cost efficiency. Traditional infrastructure requires organizations to purchase services that may remain underutilized most of the time. With AWS, organizations only pay for the computing resource that they actually consume. This pay-as-you-go model helps university manage their budgets more efficiently while avoiding unnecessary hardware investment. The five benefits is load balancing. Elastic load balancers distribute user requests evenly across multiple servers. This prevents any single server from becoming overloaded. As more students access the system, the workload is shared automatically, resulting in faster responsive times and better user experience. The sixth benefit is auto-scaling. Auto-scaling automatically increase or decrease the number of EC2 instances based on user demand. During busy period, additional servers are launched automatically. When demand decreases, extra servers are removed to reduce operating system. This allows the system to maintain excellent performance without wasting computing resource. Besides this technical advantage, cloud computing also benefits the university from a management perspective. IT staff spend less time maintaining physical hardware and more time improving the student management system itself. Because AWS continuously updates this structure, the university also benefits from the last technology without replacing existing hardware. In the future, this cloud platform can easily support additional services such as mobile application, AI-powered student analysis, online examination, learning management system, and other digital education services. This makes the system more suitable and future-ready. In conclusion, our project successfully demonstrates how a traditional student management system can be transformed into a modern cloud-based solution using AWS. By implementing Amazon EC2, Amazon RDS, Elastic Load Balancers, and Auto-Scaling Group, we successfully improving scalability, availability, reliability, performance, and flexibility. At the same time, we reduce maintenance complexity, improvement system security, and lower the operation costs. Overall, AWS provides a powerful cloud platform that enables organizations to build modern applications capable of supporting future growth and digital transformation. We believe this cloud solution is much more suitable for today's universities where reliable online services are essential of both student and organizations. Thank you very much for your attention. This concludes our presentation. We sincerely appreciate your time and we now happy to answer any question that you might have. Thank you.